for anybody that needs to be able to get to it later, they'll be able to do so. All right. Lynn, if you're in, can you put something in the chat just to make sure it's working properly?
Yes, and I'm working on making sure I'm getting people in
Okay.
and,
All right. Yeah,
and email and
if you could
emailing
help me with him,
people.
yep. I was talking to myself for a few minutes there, but anyway, we'll get rolling here now. So yeah, we're going to do a webinar on skimmer basin design. Again, my name is Jamie McCutcheon. I am a 92 grad of Clemson University with a BS in engineering. Um, owned CCAD engineering for since 1999 to about 2018, and I invented the Marley float skimmer back in 2013. I'm a licensed professional engineer in South Carolina, North Carolina, and Georgia, and have spent most of my career in land development and working, with a heavy emphasis on stormwater. So this morning we're going to talk about a few things. First is going to be just an introduction to skimmers and floating outlets. Then we're going to go through the basics of skimmer basin design. We're going to touch on South Carolina, North Carolina, Georgia standards briefly. I understand we may have a lot of people from Ohio on today, as well as probably some other states. So the standards will apply in a lot of areas, but we'll work on that. Then we're going to do a little pivot, and we're going to talk about using skimmers for post-construction. Go through some reasons why you might want to do that. A couple of case studies. We'll talk about, if you do, how you would model that in HydroFlow or another software. Um, and then we're going to wrap up with the Rymar Water Quality Filter and talk about a filtration-based design versus traditional first flush design. So we're also going to run a poll here. We'll see if they work now. So how familiar are you with skimmers? Let me back up and oop. We're going to launch this poll. All right. Now see if you can answer that. Hopefully you can see that now. All right, great. It's working. You just a few more seconds to enter that in. All right, looks like about half the people are very familiar, somewhat, some are other half are somewhat, and a few they're new. So we'll stop that. I'll share those results real quick and we'll get going. So those that are somewhat new or to skimmers or somewhat familiar, uh, traditionally we had a perforated riser for sediment basins that typically the hole is located at the bottom of the basin or possibly perforations throughout the riser structure. But the point is that traditionally we were taking the discharge out of the sediment basin from the bottom of the basin where the mud concentrations were highest. And so with skimmers, they're designed to float on the surface and meet the meet the surface withdrawal or surface dewatering requirement for sediment basins. And so the idea is they float, they take water in from the surface or near the surface where water's cleaner. They drain the basin from the top down and give more time for mud to settle and greatly increase the trapping efficiency of the basin by doing so. There are a number of skimmers on the market. This probably doesn't include all because it seems like there's others coming out from time to time. But the Faircloth skimmer is probably the most popular, most common out there. They've been around the longest. They've been around for about 25 years. Roach and Supply is fairly similar to the Faircloth. You've got the Marley float, which looks a little bit different, and then you got the IES skimmer. So maybe some others out there as well, but generally, most of them do the same thing and take water from the surface. So this is a little quick video. This is a sediment basin on a project in Anderson, South Carolina. The project's located right next to Lake Hartwell. Um, and this was right after a huge storm event. Basin was full, but I thought it was a really good example of how clean the water is coming out of a pretty dirty basin. So again, this water is being discharged. It drains. It's about 100 yards to Lake Hartwell. So very important that we keep the sediment out and even the turbidity as low as possible. So I thought it did a good job of showing the effectiveness of skimmers. So we'll touch quickly on some South Carolina sediment basin standards. So This is pretty typical everywhere. Removal efficiency, you're trying to hit 80%. In South Carolina, they want it based on a 10-year, 24-hour storm. That does vary from place to place. Sediment storage for the basin is 3,600 cubic feet per acre. That also varies place to place. And then the dewatering time is 2 to 5 days. So that seems to be the most common standard, although there are differences from state to state, but 2 to 5 days is probably the most common. One thing to point out, and this is becoming more popular for states to include, is when you size the skimmer, the orifice size and associated flow rates are product specific and should be based off product specific testing. We see that as a requirement in South Carolina and North Carolina, and starting to see more states recognize that, as they put in requirements for sediment basins and skimmers. So again, we'll talk about North Carolina standards. So North Carolina, the sediment basins are required for areas of 1 acre or more and shall use outlet structures that withdraw water from the surface, unless infeasible. Most states have that unless infeasible comment in there, but they also add that circumstances which is not feasible to draw water from the surface are rare. So extended cold weather. So, really in the southeast, that's not going to apply. You're hardly ever going to have frozen conditions to keep you from being able to do that. But if you're in like northern Ohio, colder climates, you certainly could have frozen conditions that would limit you there. So North Carolina standards, that's 1,800 cubic feet per acre of disturbed area, which is about half of what South Carolina is. They have a minimum dewatering time of two days. Again, they have requirement from the surface, and they have that again, the 2 to 5 day range is what they specify. And they do say that any skimmer that dewaters from the surface at a controlled rate is acceptable. So, and let's do one question in chat, and I'll get to that in just a second. So Georgia, again, similar requirements. Also, Georgia has that product-specific testing for the flow rates in their green book. And then Georgia has this standard chart that you put on your plans. So it's got the pond length and width, time to drain, skimmer dimensions, manufacturer's name. One thing we like to point out in the time to drain, instead of specifying a specific time, say exactly 48 or exactly 72 hours, we recommend establishing a range of time that would be allowable for your project. Now that's up to an engineer. Georgia doesn't have any specific time frame that they require. But in doing so, if you specify one skimmer and a contractor wants to use another one because they've got it on hand or whatever, it's going to be a lot easier to hit a range of time versus a very specific time frame. Again, minimum requirements here, 67 cubic yards per acre. It's at 1,800 cubic feet. Got a comment about receiving sound for this. So if anybody's having issues with sound, let me know. Hopefully everybody can hear me. So I'm going to answer the other question here on chat. It says I have a general question we answered about regarding sediment with the basin. We're asked to maintain a 2-to-1 distance between the inlet to the outlet and the width of the basin. Is any report or data on the sediment over distance in a pond? That's a fairly common requirement. I see requirements of 2-to-1. Also see some maximums of like 6-to-1 or maybe 10-to-1, so you don't channelize the flow too much. In general, like this chart shows, a lot of places have surface area requirements. So the idea is you want to give the pond, you'd rather have a shallower, wider, larger pond area than a deep, narrow pond, just so that you've got more area for the water to spread out and for it to, all right. So maybe two people are having sound issues, but hopefully you can get those corrected. If not, Lynn, just type in that this will be available on our YouTube channel if anybody's having issues getting to it.
Yeah, they've
So,
got it now, Jamie. They have
okay.
it. They said it's working now.
Okay, good deal. So real quick, just going to review a couple of standards just for comparison purposes more than anything. South Carolina, again, 3,600 cubic feet per acre, and that's based on the total area going to the basin. North Carolina is 1,800 cubic feet per disturbed acre, for your basin volume, which can be significantly different. If you've got a lot of offsite water coming to your basin, but not disturbed, North Carolina basins can be smaller. Georgia's 1,800 cubic feet per acre. I haven't found where they specify whether that's disturbed or total. That may be up to the MS4 or kind of the engineer to determine. And then Tennessee requires 1,800 cubic feet of dry storage plus an additional 1,800 cubic feet of wet storage or sediment storage, which would be below the invert of your skimmer outlet. Ohio also has the wet storage requirement, as does Indiana. So for those that are joining us from those areas, they have 1,800 cubic feet in Ohio. They actually have 5,600 cubic feet in Indiana, so much larger basin requirement, plus an extra 1,000 cubic feet for sediment storage based on the disturbed area. Surface area, a couple of different requirements out there. They generally come out to about the same amount of area required. Principal spillway, that's going to be your skimmer, plus if you have a riser at the top of the riser. So typically a 2-year or 10-year design storm is what they're looking for. Emergency spillway, obviously that's just your overflow. So anywhere from a 10-year to 100-year storm requirements. Where are skimmers required? 10 acres or plus in South Carolina, North Carolina down to 1 acre. Georgia, I'd say, is preferred. It's not in the manual as actually required, but a lot of MS4s do require it. And then in Tennessee is 10 acres or 5 acres if an impaired watershed. And then last thing here is dewatering time. Again, 2 to 5 days is kind of typical. Georgia has no standard, leave it up to the engineer, and Tennessee's 1 to 3 days. So I mentioned earlier about the states requiring flow rates based on testing. So this is a chart. This is actually from a study that was done by TRI Environmental. They did this for Georgia when they were updating their Green Book or erosion control manual, and just points out the differences in skimmers. So this on the right here is 3 different 3-inch skimmers. Their test tank is 4 feet deep. It goes 1 to 4 feet here. And you see at a 1 foot depth, 2 skimmers were pretty close in flow, around 37 GPM, and one was almost double at 70. As you increase depth from 1 foot to 4 feet, it goes from about a 25% increase in flow rate as you go up. Again, 2 of these are close to 50 GPM, so they're not far apart, but the other one is at 90 GPM, so almost double again. So the main point there is if you said simply a 3-inch skimmer and did not give any other information on your plans or details as far as what you're looking for, and you intended to use one of these that flows slower, you could get one that discharged a lot faster and vice versa. And so it's really important on your plans to identify the flow rate you're looking for and that dewatering volume that you're basing the design on. So to help with that, we've got a couple of design tools. These are on our website, free to download there. This one is based on a dry pond. So you would have all your project information, so your date, project name, project location, company, engineer, etc. Your basin description. So this is Sediment Basin 1. We've got a little check here that we've included, and this was incorporated due to some comments from reviewers. So we want to make sure what the required dewatering volume is. So you just put in your area to the basin and the volume per acre required for that area to come up with that required volume. Then here in the tool, you're going to put in your range of times, so your max and min. Again, that defaults to 2 to 5 days, but you can change that. Your pond depth. Now, the pond depth does not need to be the total depth of the pond. It's whatever depth you're meeting your required volume at. So if your pond's 8 feet deep, but you're only using 3 feet of that depth to meet your required volume, that's what you want to use. Your top length and width and your bottom length and width. You plug that in, it'll calculate the pond volume. Now recognize there's very few ponds that are square or rectangular. And so you're going to use your engineering judgment to adjust these numbers. We recommend trying to get the calculated volume within about 5% of the required volume. Again, because most times you're trying to hit a range of time. So when you do that, I know this is probably difficult to read, but it'll go through and calculate the drainage time for all of our skimmers with each orifice configuration. And then here at the bottom of the page, there's a skimmer report page tab. If you click on that, it'll take you to a nice, neat 8.5 by 11 sheet. The top of that is going to give you all of your information. It's going to give this check here to show the reviewer, hey, our required volume is this, our calculate is this, we're very close, so it's reasonable to use that. Here's the minimum flow rate to drain in the maximum time, the maximum flow rate to drain in the minimum time. And then, it is our tool. So we're going to tell you based on your selected drawdown time, which skimmers meet that. And then as the engineer, you're going to select whichever one you feel is appropriate for your project. We generally recommend trying to hit between 2 and 3 days. That seems to be, the most accepted standard out there. So in this case, I'd probably go with our 2-inch skimmer with a 2-inch orifice. It's going to drain that pond in just under 3 days. Kind of ideal time frame for that. You could go on up to our 4-inch skimmer with a 2-inch orifice. It's going to drain it in exactly, right at 2 days. So as fast as possible, assuming that's your minimum requirement there. Or you could use one of the others that takes longer. Again, up to you as engineer which ones you prefer, but we'll give you those choices. We also have some sediment basin details on our website. They have been developed over working over multiple states, and they incorporate a lot of things. Someone asked earlier about the minimum length to width ratio. So that we've got it on ours as 2-to-1, and then we have a max of 6-to-1. Now that's based on majority of states. There are some states that don't have that requirement, so you can edit this as needed. They're available in PDF and CAD, so you can easily edit them. The minimum volume required, again, we typically see 1,800 to 3,600 cubic feet. Again, Indiana's 5,600 cubic feet. Not sure we have anybody on from Texas. Texas is typically a 2-year, 24-hour storm. So you can have a pretty large volume depending on your storm event for the area there. So you could have, probably 5,000 to 6,000 cubic feet would not be uncommon for a 2-year, 24-hour storm. Surface area requirement. One of the main things here is establish your range of time on your detail. So we've set in 48 to 120 hours. Edit that as needed, but establish that range. So then down here at the bottom, we have a data block for the basins. You can have multiple basins on one detail. So it's going to give your total drainage area, the disturbed area, your flow. This may be your 2-year, 10-year, depending on where you are. Basin volume, again, want to list both required and provided. The surface area, you just want to make sure that you've got your required is, at least meets the provided, or your provided meets the required, excuse me. Outlet invert elevation, so that's going to be where your skimmer connects to your outlet, your barrel pipe size. This one is for like more of a temporary detail or temporary basin that is not, doesn't have a riser structure. Skimmer size, orifice diameter, skimmer manufacturer. Is an equal allowed, yes or no? Most of the time that's going to be yes. And we recognize, most engineers say or approved equal in most cases. There may be some times where you say no, which we'll get into probably more on the post-construction side. And then skimmer flow rate. Here you're going to establish that minimum and maximum. So if you say an equal is allowed and what that range of flow rate is, then it's very easy to do a shop drawing to determine if another skimmer meets that flow rate range required. So again, this is more the temporary basin without a riser structure. We've got and that would be a dry basin. This one has got a riser structure here with a permanent pool. And there's versions of this detail for both a riser with a dry and a temporary with a wet. So 4 different versions of the detail that we make available for you. The main difference here on the wet is including the sediment storage required and provided. Everything else is pretty much the same. This is our standard detail. A couple of things just to point out on it. So I know you can't read this up top, but all of our details include a little chart here that provides the flow rate for the skimmer with each orifice configuration. Our skimmers come, with a standard size. So this would be our 4-inch skimmers. That'd be a 4-inch orifice. And then they have other orifices available. So in this case, we go 4, 3, 2.5, and 2. So you can reduce the flow rate down as needed with this orifice plate to reduce the flow in that skimmer. We provide a flexible coupling here. It's shorter and a little stiffer than most other skimmers, kind of helps keep the skimmer in place. One of the big questions we could ask is the length of this pipe. So we don't supply that pipe, but we recommend that it be 1.4 times the height of the riser at a minimum. Also, we typically say like a minimum of 8 feet. You don't want to, if your riser is only like 2 feet tall, you want to have more than a 2.5 or 3 foot, piece of pipe in there. So give it a little bit of room to function. The other thing we call out is a 12-inch deep depression under the stone. I mean, for under the skimmer, so that your skimmer actually sits a little bit below your outlet. You'd want to do this so that the skimmer drains as much of the pond as possible. This is kind of a good picture example of that. So this is actually, obviously a freshly constructed basin. It's got the baffle in, they track the sides. It's got a little rainfall, must have happened, right after they got it in, but it looks pretty good. But the stone pad is here, and it's basically at the same elevation or maybe even slightly above the elevation of the outlet. So that bottom 6, 8, maybe even 10 inches of water is not going to be able to get to the skimmer to get discharged. So we would prefer to see that excavated, skimmer sitting a little lower, and that way the pond can drain, maybe not entirely, but majority of the pond can drain out there. Not all skimmers are installed correctly. So this is probably one of the worst installs we've ever seen. If you look here at this picture, there's no flexible coupling. I don't know how they even attach that. If you look at the side here, they've opened this valve, so water's probably just bypassing anyway. Often with a skimmer, you don't need your check dam in place. The skimmer's going to do that for you, so you can save that cost. So anyway, unfortunately, sometimes contractors do some things that don't make sense on site, but hopefully this is a rarity. We have seen some installed upside down. This one was installed upside down and had no pipe. So the good thing about that is it can't float up. So the pond's still going to drain for the most part. But, we actually have a label that says install this side up and include a QR code on the label to an installation video so that any contractor that's not sure how to do it, they can get to a little quick 5-minute video to show them exactly step by step how to get the skimmer installed correctly. And then this isn't one of ours. It's a different brand, but it had a vegetation root ball, in it. So vegetation was growing out of the skimmer. See, this basin was holding water. The pipes, up on some sediment here, so really need some maintenance. But skimmers are not maintenance free. There is some maintenance that is going to be required with them. So back up, that kind of concludes the skimmers for during construction part of this. Does anyone have any questions before we jump into the next session, next part of it? All right, seeing none or hearing none, let's go into permanent use of skimmers. So let's try another poll here. Um, oops, let me back up. Got to stop sharing. Didn't realize I was still sharing the last one. Apologize for that. So permanent skimmers. Have you ever considered using a skimmer permanently? Uh, Looks like just barely majorities no, but we got it, well, about even with no and considered, and then yes, a pretty good mix. That's pretty awesome. Looks like I've got about a half responded. I'm gonna go ahead and end that, share those results. So yeah, interesting that we got 5 no's, 6 considered but haven't, and 5 yeses. So for those that say yes, thank you. That's awesome. So I'm gonna stop sharing that one right now. All right. So for those that have or said no or maybe considered and not sure about it, hopefully this helps them. So let's look at a typical dry detention basin. Now we recognize if it was wet, it'd be a little bit different, maybe not quite the advantage on a wet basin as a dry, but still advantages to it. So when construction is complete, typically you're going to remove that skimmer. You're going to put in some sort of a low flow orifice here at the bottom of the pond, and you're going to size that for your first flush quantity if you're having to do water quality on the site. And then you're going to have to do something to keep that from clogging, right? Some sort of guard, trash guard, filter. I've seen French drains, perforated risers. We've got some people that use little turn down units, but all kinds of ways to try to keep this low flow small orifice working, especially if it's a small orifice, right? If it's a 2 or 3 acre site, that could be a less than 3 inch size orifice. So in the fall, 3 or 4 leaves get there, and that thing's clogged up if it doesn't have good protection on it. But with skimmers, well, first off, with basins, you're relying upon the natural settling of sediment particles as they travel from the inlet to the outlet. So all of our water quality methodology for when we use a basin is settlement. Let's get it a pond, let the sediment particles settle out before they get to the outlet. But where are they settling? They're settling obviously to the bottom of the pond. So if you've got a skimmer, it's releasing the cleaner water from the surface. They are now widely accepted for construction, and they've been proven to be a very cost-effective item. So it's not a huge increase in costs to add a skimmer to a project, especially for the benefit that you get. And so if they have been so successful in construction, wouldn't it make sense to consider them for post-construction as well, especially when we're still trying to settle all our pollutants to the bottom of the pond? How much sense does it make to then discharge everything from the bottom of the pond where that pollutant concentration is highest? So they're also very good for maintenance. So again, we talked about that trash guard, some way to keep that low flow orifice clean and functioning. So this is a case study we did about how skimmers can help with maintenance. This was a pond that was in Simpsonville, South Carolina. It was I have another photo that shows it beforehand, but it basically hadn't been maintained in 20 plus years. So we literally cut timber. You can see some of these trees that are still remaining, haven't been taken out yet. That's probably 8 to 10 inch tree that were in this pond. And, this picture on the right here shows it too. So we got all that done, but then the pond was holding like 2 or 3 feet of water. You can see the orifices here, kind of through the trees there, but water wasn't getting up to those, and there was no low flow orifice. So we went back, did a lot of investigation, found out that there was a 2 inch orifice that was the water quality orifice at the bottom of this pond. And the bottom of that orifice, let me show this picture a little better. The bottom of that 2 inch orifice was 6 feet below what is now the bottom of that pond. So it had 6 feet of muck and debris built up in this pond over whatever, 15, 20, 25 years that had been in place. And so we ended up redesigning the pond. Um, you can see where we closed in the orifices here, put in some new ones. And instead of the 2 inch orifice down at the bottom, we asked the county if we could use a skimmer instead. And so we did our design, helped the client out, submitted it, and the county said, no, you cannot use skimmers permanently. And we thought, uh-oh, well, how are we going to keep this 2 inch orifice from clogging up like it did last time? So the client was pretty adamant about what a maintenance problem that would be. So we went back to the county. We found out that they had a pilot program that you could apply for. So we applied to use our skimmer as a pilot program for this basin. And after much consternation from the county engineer, she finally said, okay. And she required us to provide monthly reports for the first 12 months to make sure it was working properly, and then quarterly thereafter for a couple of years. And these are pictures from those reports. It shows it's working very well, um, not clogging, helping with this pond. So about a year later, the new owner of the site was doing some maintenance on the pond. And this pond is about 3/4 of an acre and side slopes about 1.5 to 1. And so the landscapers cut all the debris on the sides, and it all kind of fell to the bottom. And before they could get it out, we had a 5 inch rain over just a few hours. And so you see all this debris here on the left side that has been washed down to the outlet. And here on the right side, you can see, after they cleaned out the debris, because the pond was able to pretty much drain entirely through the skimmer. But can you imagine if that was a 2 inch orifice? And it's hard to tell here, but that's about 8 or 9 feet. And so if water had stayed in this pond up to that level, trying to get to a 2 inch orifice here would have been extremely difficult and very dangerous for someone to do. Um, and so, if for no other reason than maintenance and ability to minimize the clogging, we feel like skimmers are a good idea to consider permanently. So we have it's hard to see in the picture. Maybe this time it was taken off, but it was put back as typically have a rope on the skimmer. So even if it does clog up a little bit, you can pull it to the side, shake it off, and it'll get functioning again to be able to drain the pond down. So if you're going to use a skimmer permanently, then we have to know how to model that in our hydrology program, right? So, obviously when you're doing your pond design, very important that you do it accurately and you've got a accurate model of your pre versus post development flow rates and how the pond is functioning. So we're going to go through an example here on hydroflow. This is actually a project that I did in the city of Greenville many years ago. City of Greenville requires quantity control during construction. So this is going to be a sediment basin. So it would have the skimmer in there for the sediment basin, but it also had to be modeled to show we're doing pre versus post attenuation for the 2 and 10 year storm. So our site was about 5 1/4, 5 3/4 acres. Um, and we are disturbing about 2 1/4 acres here. The other 3.4 basically staying the same. It's flowing across this little service drive to an inlet. So pre-development, 5.53 acres, curve number 59, time of concentrations, just under 20 minutes. Post-development, 2 1/4 acres. We used a curve number of 86. That was for bare earth disturbed conditions during construction, kind of worst case, time of concentration at 7 minutes. And so one of the things you need to do in hydroflow is when you build in your basin, you're going to build a stage so that you have a data point to enter your skimmer flow rate. So for just demonstration purposes, we put in 0, 0.1, 0.3, 0.5, and then a half a foot up to 4 feet. Just so happens that basin is about 4 feet deep. When you do that, you'll be able to enter the flow rate from the skimmer from the detail. And so when you build in your outlet structure, you're going to have your barrel. So in this case, we had an 18-inch pipe going out. Invert of the barrel was 958 at the pond. Again, we have to detain the 2 and 10 year storms. We've got a 6-inch orifice there to help manage the 2 year flow rate. It's 1.75 feet above the bottom. We have our riser structure is 3.6 feet tall, and it's got a rectangular weir of a foot wide, 3 feet off the bottom. And then kind of the secret sauce for this is this user-defined column in hydroflow. So again, we created a stage in order to enter our flow rate off of our skimmer detail at each point here. So we're entering those flows 0.1, 0.3, and 0.5. Now, again, we did this for demonstration purposes. You may decide, hey, I can put it in every foot and that's going to generate the flow curve well enough. That's probably reasonable. It's really up to you as engineer as far as how precise you want to be in that. But we put it in at every data point we had. So if your basin is over 4 feet deep, which often it will be, you got a couple of options. You can, use that flow rate at the 4 foot depth for anything greater. You can extrapolate it based on your last 3 data points. Or if you want to, you can go back to our sediment basin design tool that we talked about earlier. That design tool breaks up your water level into 20 increments. So here you'll see I put the pond depth in at 8 feet. And that's now my total pond depth. So the design tool broke that 8 foot depth into 20 increments to give me all the different stages. And then when you do that, it's going to give you the flow rate at each one of those stages. Now this is our 2-inch with half-inch orifice, so you're seeing very little change in flow, really no change in flow over depth. But as you get into the bigger skimmers, you're going to see more of a flow rate change. And so you could, pick these at half a foot or foot increments, whatever matches up with your hydroflow. They won't change that much every half a foot, so you're probably good with that. So that's a good way to model that based on your total pond depth. Our tool uses the flow rate curve that was developed from the testing to confirm that flow rate at whatever depth it gets to. So now we go back to our pond here, our schematic and hydroflow. Normally you're going to see a low flow orifice down here at the bottom, right? You're going to see a 3-inch outlet or whatever you may use. But that's our 6-inch, our weir, and our riser. But if you look at your stage discharge curve, this is your skimmer flow rate. So you see that initial flow is the skimmer flow. It's letting the water out. Then here at 1.75, your 6-inch orifice kicks in. At 3 feet, your rectangular weir kicks in. And at 3.6, your top of riser kicks in for your flow. So any questions on modeling in hydroflow? Really that user-defined function and then how to get the flow rates for depths over 8 feet are the keys. All right. quiet audience as usual. Engineers don't like to talk or ask questions, but we're good. So if you do have some, please answer. So last part of this today, we're going to talk about is it's advanced skimmer modeling for filtration-based water quality. And so our newest product is the Rymar Water Quality Filter. So that is a schematic here. So we've got a filter that has two stages. This number one is an outer layer for debris. It's a polyethylene, basically fabric or screen. The inner is this number two. This is a non-woven. It's a material made by Absorbit. It helps with TSS. It absorbs hydrocarbons. They've got some testing to show with some help with metals. And because it does such a good job with TSS, you're going to see some sediment, some phosphorus, nitrogen, nutrient removal because of them attaching to the sediment particles. And then you've got the Marley float here in the middle of it. The idea is that the Marley float pulls the water through the filter for the top 3 feet. In the schematic, the filter's basically 3 feet deep. It's open on the bottom. So if the depth of the water is over 3 feet, we're going to let gravity do its work here and not pull that water back up to the skimmer to get discharged or pull the sediment particles back up. So going back here, this is our prototype. So going back to that pond we looked at in Simpsonville before, we've changed out that skimmer and kind of played with it as our playground research area. So this was our prototype. So it was basically a turbidity curtain, but the curtain had a screen in it to let water through. And then you had the absorbent material inside that. And then there's our 4-inch skimmer. That's what it looks like when it's dry. So it's drained down, kind of get a better idea. You can see here the filter, area that lets the screen that lets water through the turbidity curtain there. This is a good picture. You can see the turbidity of the water outside the filter compared to the turbidity of the water here at the skimmer. There's a significant difference. It's noticeable to the eye. But this is actually the outlet of that pond. And so that water pretty clear. I wouldn't drink it, but after prototyping this for about 2 years, we felt like we had come up with a design that was working well and would last. And so our field testing showed there was less turbidity and minimal sediment coming out there. And so we decided to have that tested. Again, we used TRI Environmental to do our testing. And based on their testing, we got over 90% TSS removal of this system of the skimmer with the dual filter system. So one thing about the testing, ASTM now has sediment retention standards. So it's ASTM C1746. It hasn't been out but a couple of years now, but it is a test standards for sediment retention devices. And so we simulated this as a dry pond. What we wanted to do is we didn't want to have questions about, hey, if you simulate a full pond and you have a forebay and you've got 2-to-1 minimum travel distance from inlet to outlet, and you've got the other features that a pond would have, how much of that sediment retention is based on those other features? How much is based on the skimmer and the filter? So we said, let's test this worst case. Simulate a dry pond. Let's have this sediment-laden water here enter the tank 1.5 feet or so away from our filter. Skimmer's pulling that water through the filter or it's coming underneath if it gets over 3 feet. And let's run it that way. And if we can meet a standard based on those worst case conditions, when you put it into a true pond, surely you're going to meet it there. So we did that. Again, we tested 2 versions of skimmer. We got 96% TSS on one, 92% on the other. So TRI has given us a report, third-party verification of 90% for our products. Now we have a commercial version of this. We have put it in that same pond. So this is kind of a good picture of that entire pond. You can see how steep these side slopes are, all the trash and debris. One thing to point out about this basin, it has about 40 plus acres draining to it in a highly commercially developed area that is older commercial development that has basically no other stormwater management, stormwater treatment in place. So one of the reasons this pond got so much junk and debris in it is because it just gets that much. I think it's about a 60-inch pipe that comes in here at the upper reaches of the pond, and you can see a lot of just debris. This is leaf litter primarily, but it gets a lot of trash and debris as well. And then this is our, filter skimmer once the is drained down. We do have a time-lapse camera set up, so we're monitoring that on a regular basis, keeping a good eye on it, making sure it's going to work. This has been in the pond for almost a year now, working really well, and we'll continue to monitor it until it fails. So let's just now talk about generally what would be some benefits to using filtration versus settlement when you're doing a pond design. So the number one is your peak rate of discharge, if you're getting the treatment from a filter, can be based on the filter treatment flow rate up to whatever your first quantity storm event is, right? So if you've done design with other mechanical treatment devices, proprietary devices, they all say, hey, we can handle a flow of X CFS, right? Some of them are very low, zero 0.5 to 1 CFS. Some of them can get on up into the, 5, 6, maybe even 10 CFS, depending on, how big they are. Obviously, some of those get very expensive. But when you're doing filtration, you're going to base your flow rate on your filter. You do not have to now hold that first flush quantity event and count on settlement. The other thing is your filter is going to treat 100% of the runoff from the storms up to whatever the peak rate the filter can handle. So, let's talk about, realistically in our ponds. If we're designing our ponds based on a first flush method and we get a 1/4 inch of rain over, you know, 6 hours and it hadn't rained in 2 weeks, we're getting a lot of still first flush pollution wash off into the pond, but that water's basically going in and going out at the same time, right? And so if our water quality is based on ponding to allow for settlement and we get no ponding, how much treatment we get? Really none, right? Very, very minimal treatment in that case. And then third benefit is your filtration media can be customized to target specific pollutants of concern. Like I said, we've already incorporated a product into our standard that absorbs hydrocarbons. That product has an option where it can be have an antimicrobial treatment added to it. Now, I can't say we've done any testing yet for what the treatment rate for bacteria would be with that, because sometimes that does require some contact time. But if you've got a site that needs bacteria treatment, something like that, we can help with that potentially. We definitely can help with the hydrocarbons. We haven't tested this in a pond with a hydrocarbon or the tank, but Adsorbit has the data to back it up and show it gets really, really good hydrocarbon removal for your site. So if you've got a hotspot, if you've got a truck stop, your gas station, fuel station, whatever it may be, that needs hydrocarbon removal, it'd be a very good option for that. So now let's talk about benefits of using a skimmer with filtration. So the skimmer can be sized to control the peak rate for the lower storm event. So in most cases, that's like a 2-year storm, right? So if your first quantity control event's a 2-year storm and you can size the skimmer to handle that, now you're treating that entire rainfall up to that 2-year storm. The skimmer is going to increase the filter efficiency because it's withdrawing from the surface where the water is cleaner, right? If we can move that skimmer up and down and keep it near the surface, we've got less pollution in that surface water that we're trying to screen out. So your filter is going to last longer. And then the skimmer is easy to access, pull to the side for pond, for maintenance. So obviously these things are not maintenance free. We do recommend changing them out every 2 years based on how long we kept our prototype in the pond. We may adjust that in the future if we see it can effectively function longer than 2 years, but currently that's the standard. But it's easy to get to. No confined space entry, no specialized equipment. Pretty simple to get to it and change it out, do some cleaning or changing if needed. So, what are some challenges? Okay, so this isn't the perfect product for every situation. First to admit that. So, first challenge is, like we said, filters are prone to clog over time. They will require maintenance, periodic cleaning, or changing. Again, we're recommending a 2-year time frame to change out the filters. Number two, your skimmer's got to be durable. Got to last in more than just a few years to be suitable for permanent use. One of the reasons some regs say skimmers can't be used for permanent use is the original skimmers were all PVC. And we understand PVC is not going to hold up forever with UV. So PVC is going to degrade over time. You need to use a product that's durable. Ours is a HDPE polyethylene product, so it's 20 plus year lifespan with UV. And then the final one here, and this is probably the biggest one, and I don't know how many regulatory municipal folks we have on today. There are no established standards for basis of design and permitting based upon combining a pond with a filter. Um, a lot of places have proprietary standards for MTDs, proprietary products. You have to kind of combine those with a pond, figure out how those work together. We're working through that. We're actively pursuing, like I said, we've already got ASTM certification or testing to ASTM standards and third party to certify that. We are actively pursuing NJCAT certification as well. And hopefully we'll get that in place next year. So now kind of wrapping up, I know we're getting close to our 12 o'clock time that we're shooting for, although we got started a few minutes late. Let's run through a quick comparison of a first flush model that you can release over 24 to 48 hours versus filtration model. Got a comment in chat, and Richard will definitely follow up with you on that. So let's look here at our sample sites. We've got a 5-acre site. We're going to say pre-development conditions or have a curve number of 55. Post-development, we're going to go to a shopping center, curve number 92. So first thing we're going to do is we're going to look at our pre-development flow rates. So we've got, let's say, our site, 5-acre wooded site, time of concentration, hypothetical 48 minutes. And if we had that, then our pre-development flow for 2-year storms is going to be 0.72 CFS, 10 years 3, 25, 5.4, 100 year 10.7. We're really going to focus here on the 2-year storm and water quality event. So now our water quality volume and post-development flow rates, next thing we need to do. So we're going to say, okay, our 5-acre commercial site, let's assume it's got a 10-minute time of concentration and work on that. So for our water quality storm, that generates, in South Carolina, water quality event is 1 inch of runoff volume over the developed site to a dry pond. Georgia's 1.2, 1 in Tennessee. I think it's 1 or 1.5 in North Carolina. I think it's 1.5 in Indiana. I don't know in Texas what it is, or Ohio, I think it's 1 or 1.1. So, so anyway, you've got to look at your current, whatever your state is. But right now, for this example, 1 inch runoff, we need a 1.73 inch 24-hour storm to approximate that water quality volume of 18,150 cubic feet. All right, so we run that through the model. Our post-construction runoffs are 7.2 CFS, and then our 2-year jumps up 19 CFS to 19.72. Obviously 10, 25, and 100 all jump up as well. So most of you consultants on here today probably have a first flush Excel spreadsheet that's something similar to this. That seems to be the consensus. So you got, your pond type. In this case, we're going to say dry. Contributing areas, that 5 acres. Our water quality volume required, so it's 1 inch for a dry pond. So that comes out to our 18,150 cubic feet. We're going to hold it for a minimum of 24 hours. And what's our average flow rate to do that? It's 0.21 CFS. And so if we say we got an average of 3 feet ahead, run through the model here with our formulas, comes out to a 2.6 inch orifice. Okay, so 2.6 inch orifice would release that 18,150 cubic feet over 24 hours. And so we're going to model our pond with that. So again, a hypothetical pond here has I said our pond bottoms at 110, so 3 foot of depth to get our 18,150 cubic feet. I put in a 3-inch orifice here just because, we could cut a cap or make it 2.6, but I just ran it as a 3 for the model. Then we've got a 3-inch orifice at a 3 foot depth. That's going to control our 2-year storm. We got an 8-inch orifice at a 5 foot depth. That's our 10-year storm. And then we're going to use that in a combination of the riser for our 25-year storm. So we run through the model. Our water quality event, we're releasing that at 0.25 CFS. We're only using just under 10,700 cubic feet of volume. So again, nearly 6,500 cubic feet of volume that we're required to have for our water quality event is not being utilized. So we, should be able to lower that 3-inch orifice a half a foot because our peak elevation is 12.5 instead of 113. So, but that's our standard. In our 2-year storm, we got a 0.81 CFS, so a slight increase over the 0.72 CFS. So now let's look at the alternative would be using a skimmer to there instead of that low flow orifice. So I want to try to size the skimmer for our 2-year storm. So 2-year storm has a peak rate of 0.72. Look at our standard flow rate chart. This gives the peak flow rate for each skimmer is 0.778 at that peak flow rate is at a 4-foot depth. So I'm gonna say, all right, let's model that to start with. Okay, we also have filter details. So this again, we got our outer skirt here. It's a Mirify FW402, just a woven geotextile. The inner skirt is the Adsorbit. One thing to point out here with our inner skirt, it's actually 2 layers of fabric together. It has slits in it. The slits are 6 inches wide, so it creates 6-inch tendrils or panels, and they're offset. So basically, it requires water to either go through the filter or to kind of weave through the panels, and they're very close together. What that does is creates contact time, so the fabric can latch onto or touch the sediment particles, other polluted particles, but also maintain the flow rate with the skimmer. What we found is that although material has a pretty high flow rate, about 145 gallons per minute per square foot, when they test it, when you put it in a tank vertically and just have the skimmer pulling it through, it doesn't hit that. So we needed to allow more water through it, but we did that 2-panel system with the slits to create the contact time. Other thing to point out is the length and width may vary. So our L1 and L2 may be different numbers, especially when you get to the larger skimmers. Our 4-inch and smaller are all going to use the same thing. Our 6, 8, and 8-inch max are going to use different sizes. Important to recognize, you typically don't want more than a 20-foot piece of pipe here. And so since the skimmer is going to rise at about a 45-degree angle, you don't want more than about a 10-foot length from here to there. So we set that as a max of 16 feet. Excuse me. Yeah, in there. So, all right, excuse me, max of 12 feet. So you got max of 16. You got no more than 8 feet from here to here. There, no more than 6 feet there to there. So, and then this is our basin detail. So this just shows the skimmer with the filter around it. Some of you may recall our previous details showed the skimmer kind of parallel to the bank. And in that case, we did that for maintenance, just kind of visual. With this new filter around it, it's important to kind of get it out in the pond so it's not getting stuck on the bank or getting too shallow there. But anyway, so all that's basically it for the detail. Now, if we run that through the model, what we're going to see, our water quality flow rate has gone up from 0.25 CFS to 0.7, so nearly tripled our flow rate for the water quality volume. Peak elevation's 12, and we're only using 7,600 cubic feet. So we're using just over a third of the volume required to actually do that. Also, the skimmer is now handling our 2-year storms. We got a 0.78 CFS flow rate for the 2-year storm. Peak elevation's about 4.7 feet. And so now we have one 8-inch orifice at about, just slightly less than what we had before at 114.8 instead of 115. And if you compare the storage required for each storm, you see it's less. Really, the numbers point out here is percentage difference. So you've got almost 30% less volume required, and in 14 and 12%, depending on which storm you have. So point is, you have much smaller pond with the filter because of being able to release that water quality volume so much faster and still meet your requirements. So in summary, skimmers are less prone to clog than orifice located at the bottom of the pond. They often require less maintenance to keep the pond functioning properly, right? We spend lots and lots of money on these ponds and designing the ponds and building the ponds. Let's try to get them to function properly as long as they can with as little maintenance as possible. Skimmers can be a very effective way to retrofit existing basins and reduce maintenance, provide enhanced water quality. Um, really feel like this is some of the best opportunities for not only a skimmer, but for the water quality filter. If you're doing a redevelopment and it has a pond that is existing but did not have water quality built into it, say the pond's 20 years old, 30 years old, you probably don't have volume in that pond to go back and add water quality under a first flush method. However, if you can use a skimmer and keep up your 2-year flow rate pretty close to what it was and use that for the treatment, you have a very good chance to retrofit the entire site very cost effectively by simply adding a skimmer and filter to it. And again, surface draw is going to release cleaner water from the basin for enhanced water quality, even without the filter. This is going to be true. With the filter, we've got testing to verify it. Don't have any testing without the filter, but just basic common sense tells you you're going to capture more sediment in that basin if you do the surface withdrawal. So again, our use of the skimmer with the filter has been tested to confirm 90% TSS removal efficiency per that ASTM standard. The skimmer with the filter is going to treat more of the annual rainfall. So we're going to treat the very small storm events as well as larger events, whatever's managed by the skimmer. Like I said, we try to get up to the 2-year storm, will depend on the size of your site. And then the filtration model reduces pond size by 15 to 20% over traditional first flush method. So one more poll with you. So now that you're aware of these benefits, for those of you that haven't considered it before, maybe haven't, would you consider? That's a good idea. And yeah, the yeses and maybes are true. And for the maybes, I 100% agree. This is not going to be right for every project. No doubt about it, but there are a ton of projects that it really can be right for. So I'm going to end that poll there. I'll share those real quick just to see. So we got 11 maybes and 7 yeses. Didn't have any no's, which is nice. So, all right. So wrap up real quick. I know everybody's ready to go. Is there a question? All right. So this is our website. I'm just going to do a couple of quick things for you here. We have a resources and training page. So we'll have a webinar on there. It's usually one of our last over the last month or two, maybe 3 months old. We try to keep it updated. We also have a series. So it breaks down what we talked about today, as well as some other things. Like we've got one on SEDCAD. We've got a few other things that are available on there. We'll add to that. So if you do have a question, look at that. Probably breaks it down to like a 10-minute segment for you versus trying to go find it in the webinar. Um, all of our downloads are nice and neat. We have an engineer's spec pack. It has 3 folders, so it's a zip file. When you download it, it'll have a skimmer details, the design tools, the test data, any supporting information, maintenance recommendations, etc. We'll have a sediment basin detail, and then we'll have a water quality basin details, design guidance, test data, supporting information for the water quality filter. Again, our product is HDPE. It's very UV resistant. It's got, just pivots in one place, really no other moving parts. It does have this debris guard around it. So anything that's floating in the basin has a hard time getting to the orifice to clog it up. It will continue to work in mild frozen conditions. If you're in an area that has severe freezing, we recommend adding a valve to a perforated riser in the bottom of your basin. That way you can cut that valve on if it's frozen. Uh, Talked earlier about our orifice plates. So this is it. This is a video here. I'll show you how that works. So each skimmer comes with a EPDM rubber sheet that has the different orifice sizes. Our 2, 3, and 4 just have one that just you rotate around. The 6 and 8 have multiple ones in there, but it has a little metal nub here to make sure the orifice is centered over the pipe correctly. Make it very simple for contractors to get the orifice sizing correct. Again, all those have been third-party tested to verify. Our product always stays level. Prior version, about 4 years ago now, weighted a little bit differently. And so we redesigned it back in 2019. And now all the weight's in the bottom. And so hopefully nothing ever happens to your skimmer like Aaron's doing to this one here. But just to demonstrate, it always stays level for you. Um, we have custom molded floats actually for our 3, 4, 6, and 8 inch. Our 6 and 8 have handles built in. They're pretty heavy. They weigh about 200 pounds a piece. We try to make it easier for contractors to do. We have 6 different models, 2 inch through 8 inch, and then we call our 8 inch with 8 inch pipe or 8 inch max. Um, one thing to point out, our standard 8 inch has a 6 inch um, uh, barrel, so 6 inch pipe connected to it. It still has a flow rate that's about 0.5 to zero point 0.6 higher than most other 8 inch skimmers. And our 8 inch with 8 inch pipe, we sometimes refer to that as our 8 inch max, has a flow rate that's nearly double other 8 inch skimmers. So if you have large sites that, we're seeing a lot of solar farms out there that have huge basins. And so you may be able to go from having multiple skimmers to one, or at least fewer, by using our 8 inch max. Um, I didn't talk about HydroCAD, but we are available in HydroCAD, so we're all built in to make it a little easier to model. And that's really it for today. Because we got started late, I'm going to go just kind of skip over our VersaWaddle. I'll go through just a product. You can see it on our website. It's designed to go down on as an inlet protection, particularly where you don't have final asphalt down. So it kind of traps some sediment, kicks water over the curb, designed to be driven over. So, a lot of problems you have is that type of stuff. If it gets, especially if it gets hit by a dump truck, it doesn't last very long. But ours do. So if you have interest in that, you can check that out as well. And then it also can be used like this is a commercial lot, so it's got a inlet in the middle of a parking lot here. So it's really good to provide sediment control there. And then it also can work on a sag, so it'll let that water filter through, but it'll help keep the sediment out of the basin. So that's it. Thank you for attending. If anybody has any follow-up questions, I saw a few things in the chat that we need to follow up with some people on. Um, Dave said, I think Lynn or Richard are going to reach out to you about details, so you can get those off our website. You can scan the QR code, or you can just email us if you need a PDA certificate. We'll be glad to send those out. They are self-reported. For some of you, you've got areas that require a approval. We're working on getting a couple of those right now, but for the most part, I think you're good for to at least get a PDH credit out of this. So if you do need that, just email us at info@Rymar Waterworks, and we'll get that right out to you. I want to thank everybody for joining us today. Sorry for the technical difficulties on the front end there, but we'll get those correct next time. And if you have any questions, please unmute, or you're welcome to ask in chat.
I'd asked, this is Josh, I'd asked a question earlier and then I had to get off, so I probably missed the response. You said the video is recorded somewhere and accessible?
It is, and your question was about the 2-to-1 distance.
Yeah.
Yeah, so what we see on that, Josh, is it does vary state to state on requirements. That is a fairly common one. I think the general idea is they want to have enough area for to spread out. What I have seen on some others is a maximum ratio of like 6-to-1 or maybe 10-to-1, so you don't create like a channel going in there. But that is you want to generate that travel distance. To be honest, a lot of that's probably based on just historical before skimmers
Right.
became common, before baffles became common, that kind of stuff. In practice, I haven't seen that enforced strictly if you've got the baffles in place and other things, but obviously that's going to be up to your local reviewer.
Yeah, my issue was, I wanted to know what evidence they have of, how long it takes for the sediment to kind of just fall out because, I had a basin that was, I think it was about 5 acres. And, so my inlet and my outlet were probably about 200 feet apart, but they weren't 2-to-1 because it was a very large basin in another
Right,
direction.
right,
And so I'm like, well, I'm over 200 feet away. That stuff's got to settle out,
right.
So I just wanted to find some kind of data out there. And I thought I'd ask since, you
Yeah,
guys are
I
talking
have.
about a little bit about it.
Yeah, I've seen like some general information, and I know you could probably um, run a Stokes law equation kind of thing on it
True.
to do it. Um, but yeah, I agree with you. If you've got 200 feet, that should be plenty, regardless of your length width. I mean, the intent
Yeah.
of that has always been, let's don't short circuit, right? Let's give it a little bit of
Right.
time to get there, which does make sense. Yeah, yeah, you've got a challenge from a reviewer that is reading a book versus looking at intent.
Yep.
So, yep,
Exactly.
yep, we've all been there, and for whatever reviewers are listening in, I don't mean to offend anybody, but but I think for those of us that have been in this for any time, recognize that hey, let's focus on meeting the intent of what we're trying to accomplish, and
Right.
not necessarily letter of the law on every little thing. So. Yeah,
Thanks.
I don't have any. If I have any specifics I could share, I would. I can't think of any, but I'll go back and look. If I have like that, I'll be glad to send it to you.
Okay.
All right. Thank you for joining. Thanks for everybody else. Hope you all have a great day. If we can be a resource, please let us know. One thing I forgot to mention, if you are looking at the water quality filter, for those that are still on, if you've got a specific area that you'd like to use it, please reach out to us and give us a heads up. We'll make sure to go to that area and talk to them and make sure they're okay with it. It is new, it's a novel concept. Sometimes that's hard to break in and get reviewers to accept. So, let us plow that ground for you. Don't, if you want to do it, we'd love to have you, but we're also very willing to jump in and help. So, um, just let us know where we need to go talk. Thank you.
Thanks.
Have a great day.